Welcome. We will be looking at derivatives of the exponential and the logarithmic functions. So I'm going to start with two facts. The first one is that the derivative of e to the x is equal to e to the x for any x. So e to the x is differentiable for any real number x, and the derivative of e to the x is itself. And it turns out that this is a very special function in the sense that this is the only non-zero function whose derivative is itself. That is, the rate of the function is equal to the function itself. And the second fact is that the derivative of ln of x is 1 over x for any positive x. So ln of x is differentiable for any positive x, and its derivative is given by 1 over x. Now recall that the domain of ln of x is the set of all positive real numbers, and the domain of the exponential function here is the set of all real numbers. So let's say use these formulas. So let's say we want to differentiate the function f of x is equal to 4 e to the x plus 8x squared plus 7x minus 15 e to the power 4. So now I want to find the derivative. So because this is a sum, we can find the derivative term by term. So the derivative would be the derivative of 4 times e to the x. Now remember, the derivative of e to the x is itself, so the derivative of 4 e to the x would be 4 times e to the x. The derivative of 8x squared would be 8 times the derivative of x squared, which is 2x. So eventually you would get 16x here. And the derivative of 7x would be 7. So the derivatives of these two terms are found by using the power rule. And negative 15 e to the power 4, well, e is a constant, so it's a fixed real number, so this entire quantity is a fixed constant, so the derivative of that is 0. So simplifying, we see that the derivative is 4 e to the x plus 16x plus 7. Okay, so let's now find the derivative of the function y is equal to 10x squared minus 70 ln of x. Well, again, we take the derivative of the first term. Well, that would be 10 times the derivative of x squared, and the derivative of x squared by the power rule would be 2 times x. And here we get 70 times ln of x, so that will be 70 times the derivative of ln of x, and the derivative of ln of x is 1 over x. So simplifying, we get 20x minus 70 divided by x. Okay, so a bunch of exercises now. We want to differentiate the function g of x, which is equal to x to the 7 minus x to the 5 plus e to the 3 minus x plus e to the x. So g prime of x would be 7x to the 7 minus 1 minus 5x to the 5 minus 1 by the power rule. The derivative of e to the 3 would be 0 because that's just a constant. Derivative of negative x would be negative 1 by the power rule, and the derivative of e to the x is itself. So simplifying, we get 7x to the 6 minus 5x to the 4 minus 1 plus e to the x. Y is the function of x and y is equal to ln of x to the 5 plus e to the x minus ln of 10. Now, sometimes when log is involved, sometimes we might want to use the properties of the log function to simplify the function and then take the derivative. So here, ln of x to the 5 can be rewritten as 5 times ln of x. So when we take ln of x to the 5, this 5 can be brought in front of the log by one of the properties of the log. So we get 5 ln x plus e to the x minus ln of 10. Now we take the derivative. So the derivative of 5 ln x, well, that should be 5 times the derivative of ln x, which is 5 times 1 over x. The derivative of e to the x is e to the x itself, and the derivative of ln of 10 is 0. So simplifying again, we get 5 over x plus e to the x. Okay, so so far we have so what we have done is we looked at the derivatives of the function e to the x and the function ln of x, and then we computed derivatives of functions involving these two functions. In the next so what we want to do now is the following. We want to look at other exponential functions with with the base different from e, and other log functions where the base isn't e. So before I do that, let me derive two formulas for the log function and the exponential function. So here, if y is equal to log of x base b, then we know that b to the power y would be equal to x. And so right now, look at the second equation, and we're going to apply the natural log ln on both sides. So we get ln of b to the y. Now ln of b to the y is y ln of b, and here I get ln of x. So now if I solve for y, I get ln of x over ln of b. But remember what y is. Y is log of x base b. So what we are getting then is log of x base b is equal to ln of x over ln of b. So in other words, log of x base b can be expressed in terms of the natural log in this way. So one nice thing about this property is that if my calculator doesn't have a function for an arbitrary base, then I can use this for a calculator always has this ln function. So I can use this formula to calculate the log of a number base any with any base if my calculator can only handle ln the function ln. The second formula that I'm going to be looking at is the following. So if y is b to the power x, then notice that if I apply the natural logarithm on both sides, then I get ln of y here, and ln of b to the x is the same as x ln of b. So this is what we get. Now I'm going to raise e to the two sides here. So e to the power ln of y. So recall that e to the power ln of y is going to give me y back, and then I get e to the power x ln of b. So then I get that y is e to the x ln of b, but y was b to the x. So I see that b to the x is the same as e to the x ln of b. So b to the x is e to the x ln b. Okay, so so these are the, so basically if I have any exponential function with a base different from e, then I can always express that in terms of e in this way. So we have obtained these two formulas. Okay, so the question is, what's the derivative of b to the x, and what's the derivative of the function log of x base b? The derivative of b to the x is b to the x times ln of b. So if I have e to the x, remember the derivative is just e to the x. But if I have a base which is not b, which is not e, then the derivative is given by this formula. And also the derivative of log of x base b would be equal to 1 over x times ln of b. Now recall that if I have the natural log here, then the derivative is just 1 over x. So if I have a log with the base other than e, then with the base different from e, then the derivative would be 1 over x times ln of b. All right, so we're going to apply these two formulas in the next couple of examples. So let's say I want to find the derivative of x to the 10 plus 10 to the x minus 6 to the x. Well, the derivative of x to the 10 is 10, by the power rule would be 10x to the 9, and the derivative of 10 to the x by the formula that I just showed you here. So the derivative of 10 to the x would be 10 to the x times ln of 10. So, and the derivative of 6 to the x would be 6 to the x times ln of 6. All right, so let's say I want to find the derivative of log of x minus log base 5 of x to the 6 minus ln of e to the x. First of all, when you write log of x without specifying the base, but the base is by default 10. And now log of x to the 6 here can be rewritten as 6 times log of x. This is by one of the properties of log that we talked about before. And then then this is also ln of e to the x is just x, because recall that these two functions are inverses, so you get x here. So now we can take the derivative, and we're going to apply the following. This formula right here, the log of x base b is 1 over x ln of b. So here the log of x base 10 would be 1 over x log ln of 10 minus 6 times the derivative of log of x base 5 would be 1 over x ln of 5, and the derivative of x here would be 1. So this is what we end up with. Okay, so let's say I want to find the equation of the tangent line to the graph of the ln of x function at the point where x is e cubed. Well, again, we do the same thing as we did before whenever we wanted to find the equation of a tangent line. So the first thing I need is the slope, and the slope is given by the derivative of the function. So let's find the derivative, and the derivative we know is 1 over x, and when x is e to the 3, then the derivative is 1 over e to the 3. So that would be the slope of the tangent line to the graph of the function here at this point. Now so notice that when x is e to the 3, so I'm going to label this point as x1. So x1 is e to the 3, then the corresponding value of the function, I'm going to label that as y1. So y1 would be f of e to the 3, which would be ln of e to the 3, but ln of e to the 3 is 3 because of the properties of the log function. Excuse me. So now we have the point and we have the slope. So the equation of the tangent line would be y minus y1 is equal to n times x minus x1. So we just plug those in. So y minus 3 would be 1 over e to the 3 times x minus e to the 3. And then if we simplify this, we get y minus 3 is 1 over e to the 3x minus 1. And finally, we get y is 1 over e to the 3 times x plus 2. So that's the equation of the tangent line to the graph of the log function at the point where x is e to the 3. Okay, so we want to find a couple of derivatives and simplify. So let's say f of x is e to the x times x to the e. So the derivative of e to the x is e to the x, and here x to the power e. So e is a constant power here. So here we can apply the power rule. So this would be e times x to the e minus 1. We want to find the derivative of the function y is equal to ln of x to the 6. Now, before we find the derivative, we're going to rewrite that as 6 times ln of x. So now the derivative would be 6 times the derivative of ln of x. And the derivative of ln of x is 1 over x. So you get 6 divided by x. So this is this function in B. That's what I have in part C. I want to find the equation of the tangent line to the graph of f at the point x is equal to e. So the derivative is 6 over x. So the slope would be f prime of e, which would be 6 over e, and the point on the graph of f corresponding to this x value would be the following point. So if I'm going to label x1 to be e, and then f of x1 would be or f of e would be y1, which is ln of e to the 6, which is equal to 6. So we see that we want to find the equation of the tangent line to the graph of the function at this point here, where the x coordinate is e, the y coordinate is 6. So the point slope formula for the equation of a line is here. We just plug in x1, y1, and the slope would be 6 over e. And then we simply simplify that. So we get y minus 6 is equal to 6 over e times x minus 6 let's see. Okay, so I have a typo here. So this should be 6 over ex, and then when you multiply 6 over e and e here, you should be getting negative 6. So I should have a negative 6 here, and so this should have been y is equal to 6 over e times x. So there shouldn't be any 5 here. Again, that's because when I multiply 6 over e with e, that's going to give me a -6 here. So this should have been a -6 instead of -1. And so y should be just 6 over e times x. So the 5 shouldn't be there. Okay, so I'm going to stop the video here, and in the next video we will be looking at two other examples.